is this sort of coming together a little bit? So all we're saying is that if you move the light clock, then the photon is being forced to take a longer path than it would have if it were at rest and just had to move up and down. Because you've added this motion, it's also translating, and it's going to be taking a longer path. But unlike a normal particle just moving up and down, say a bead that's vibrating, if I take a bead vibrating between two surfaces and move it, it just gains the speed of translation. Whereas a light particle can't. Photon, the speed is fixed. So if I force it to take a longer path, then it's going to take longer to carve out that trajectory. And so the light clock is slowing down. So you might say, okay, well, your silly, goofy light clock's slowing down, but that doesn't mean that time itself is slowing down. So let me try to convince you that it is time that is slowing down by making this other argument. If you were moving with the light clock, you wouldn't see it taking that diagonal path. You would see this particle moving up and down in this motion, and you wouldn't notice that the light clock is actually slowing down. Broken clocks read the same broken time to everyone. This isn't a matter of the clock breaking. One observer is literally and physically observing the light clock slow down, while another observer is seeing the clock tick off at constant rates. There isn't an objective failure of the clock. It is that time is literally and physically passing differently for one observer than a different observer. So that's pretty nuts if you think about it. Now these effects are only appreciable if you're moving at a substantial fraction of the speed of light. Light is so fast that we don't notice these effects on an everyday basis. There's a guy by the name of Brian Greene, and I put some of his videos in the homework. He was the guy that converted me to physics. And he used to say in one of his books, these effects aren't noticeable, so just imagine that they're happening, because they are. As you drive down the freeway, time is moving a little bit slower for you compared to somebody that's sitting by the freeway. What we've established so far, if we've been somewhat successful here, and I have been very brief on this, is that time slows down the faster you go.